Assalamualaikum and a very good evening. This is Group Al-Kawarizme. We will be presenting about game theory, which is one of the discrete mathematics contribution. So, this is our group members. So, game theory is a branch of mathematics that deals with the study of strategic interactions between different players. So it is a tool used to model and analyze decision making. It can be in social sciences, economics, and politics, and it can also apply to many more. So the intention of game theory is to produce optimal decision making of independent and competing actors in a strategic setting. So using game theory, real-world scenario for such situation as pricing, competition, and product releases can be laid out and their outcomes predicted. However, it really depends on various requirements and assumptions. So I pass on to the next presenter.
Moving on to the history, game theory began in the early 20th century with John von Neumann and Oscar Morgenstern's book on games and economics. They used math to model how people choose in different situations. In the 1940s, John Nash developed the idea of Nash equilibrium, which shows that no player can improve by changing only their strategy. This is a key concept in game theory for many applications. Game theory has been used in various fields such as economics, politics, psychology, sociology, computer science, and artificial intelligence. It helps to understand and create strategic interactions between players. Discrete mathematics has helped game theory to create powerful tools for studying decision making in today's world. Next, I will pass to the next presenter.
Okay, so for the inventor of game theory, uh, the game theory was developed by John von Neumann, who was a Hungarian American mathematician, physicist, computer scientist, engineer, and polymath. He was a major contributor towards many fields, such as mathematics, which he introduced measure theory, group theory, and lattice theory. In computing, he contributed to the von Neumann architecture, linear programming, and scientific computing, and also statistics. So John von Neumann got the inspiration of game theory from poker, which he played occasionally. And he publicly introduced game theory in a 1928 article called Theory of Parlor Games.
Right. So moving on to the usage, I will be presenting four of the usage in game theory. So the list is extendable, but I'll just present four of these. Firstly is negotiation. Game theory assists in understanding how to negotiate with others in order to attain your objectives. The present dilemma, for example, is a classic game theory situation in which two suspects must decide whether to confess or remain silent. You may make better selection or decision when negotiating with others if you understand the incentive and the outcomes of each option. Next, in political science, game theory can help us understand how politicians make decisions. Understanding how different groups vote in an election, for example, or how countries negotiate a peace treaty can be evaluated using game theory. All right. Thirdly is social interaction. In social interaction, understanding how people interact with one another in social circumstances can be aided by game theory. The iterated prisoner's dilemma, for example, is a game that replicates how people might interact with one another over time. You can better handle social relationships with others if you understand how cooperations and defection can result in diverse outcomes. Lastly, business strategy. Strategic decisions can be aided by game theory. Businesses, for example, might use game theory to predict how their competitor will react to particular pricing, tactics, or marketing efforts. I'll pass it to the next person.
Okay, for the effects, effects is divided by two category, which is the benefits and the disadvantages. For the benefits, some of them are strategic decision making. Game theory can help individuals make better decision in strategic situation where the outcome depends on the choice of the individuals. By modeling the incentive and potential outcome of different strategies, game theory can help individuals make more informed and strategic decision. Other than that is business and economics. Game theory is widely used in business and economics to understand the behavior of firm and markets. By modeling strategic interaction between competitors, game theory can help firm make better decision about pricing, production and other strategic factors. Public policy is also some of game theory benefits. Game theory can be used to model the behavior of individual and organization in the context of public policy, such as in voting system, taxation and regulation. By understanding the incentive and strategic interaction of different stakeholders, policymaker can design more effective policies. Lastly is resolution. Game theory can also be used to model and resolve conflicts between individual or groups. By understanding the strategic incentive and potential outcome of different conflict resolution strategies, game theory can help individuals and organizations resolve conflict more effectively and efficient. Next, move on to the disadvantages of game theory. Firstly is simplification of human behavior. Game theory often assumes that humans are rational decision makers who always act in their best interest. However, humans are complex creatures with emotion, biases, and social norms that can influence their decision in ways that are not easily captured by game theory models. After that is ethical concerns. Game theory can be used to model situations where individuals may be incentivized to behave unethically or harm others in order to achieve their goals. While this may be useful in some academic or business setting, it can raise ethical concern when applied to real life situation. Limited predictive power is also a part of the disadvantages of gaming theory. Game theory can help us understand the strategic interaction between individuals. It cannot always accurately predict how individuals will behave in practice. In some cases, human behavior may deviate significantly from what is predicted by game theory models. Lastly is complexity. Game theory models can be highly complex and difficult to understand for individuals without a background in mathematics or economics. This can limit the usefulness of game theory in everyday life, where individuals may not have the time or resources to fully grasp in its implication. I'll pass to the next presenter.
So we'll move on to the examples of game theory. The first one will be a normal form game. This is a form of game that is a true dimensional grid, being the possible strategies and outcome of a game. The strategies of each player are shown along the horizontal and vertical axis, and the outcomes of the game are listed in the cells of the matrix. This is a simple and widely used method for representing games. The second example would be an extensive form game tree. This tree-like diagram is used to represent the sequence of moves and actions in the game, with each node representing a decision point and the branches representing the various options available to players. It is often used to analyze games that have a sequential framework. The last one would be the Nash equilibrium graph. A Nash equilibrium is the outcome of a game in which no player can improve his payoff by changing his strategy when the strategies of the other players are known. It is often used to analyze games where there are multiple strategies to choose from. on to the next presenter.
Okay, so now I will present about limitations of the game theory. So one of the limitation is the assumptions about rationality. So game theory assumes that all players are rational and will always act in their best interest. However, people often make decisions based on emotions, social norms, or other factors that are not captured by assumptions about rationality. So the second one is it has limited scope. It is often limited to a specific set of scenarios and does not capture the complexity of real world interactions. For example, it does not consider external factors such as economic changes or unforeseen events that may influence decision making. So the third limitation is it has simplified modeling. To make the mathematics manageable, game theory often relies on simplified models that cannot accurately capture the nuances of real-world interactions. This can lead to inaccurate predictions and limited applicability. So the fourth one is the difficulty in predicting outcomes. So even if a game is well defined and all players act rationally, predicting the game's outcome with certainty can be difficult. This is due to the fact that game theory assumes that all players have perfect information, which rarely occurs in practice. Next slide. Okay, finally, uh, one the final limitations of game theory is it has limited usefulness in non-zero sum games. So game theory is particularly useful for modeling zero sum games, where one player's gain is always another player's loss. However, it may be less useful for non-zero sum games where there are opportunities for mutual gain or cooperation. I will pass to the next presenter.
So to close our presentation, we present our conclusion. So game theory is an essential contribution of discrete mathematics that has had a significant impact on human life. It has been used to model and analyze strategic interaction between players in various fields, such as economics, politics, and psychology, and computer science. Then, game theory has led to new insight and theories that have helped solve real-world problems and advance our understanding of decision-making processes. So that's all from us. Thank you.